proof of concept ransomware built on top of the Solana blockchain. Alright, so I wrote this when I was 17 years old, a year and a half ago, and this was just like a side project that I really wanted to analyze, and I completely forgot about it because I was so busy doing stuff. And then there's also this, which is the forwarder, like how you handle the ransomware payments. And this is in Go, and that's why it's 70% Python and 30% Golang, since the stub is in Python and for some reason the C2 is in Golang. And I don't know why I made it differently. It's all good, but alright, so this is what actually runs when you run the file, and obviously the stub is what you're supposed to create as an executable to run. So I'm just gonna run through the step. That's gonna take a little bit. Check if encryptor is already running, and let's go into there. This, what I did was I put a magic file somewhere deep into the local app data because I needed to check if I was encrypting myself. Since say they restarted the computer and everything was already encrypted, you don't want to encrypt the already encrypted files, since then you'd have to send that over and then you'd have to do multiple things. It's just like, it's a hassle. And this is an easy way. This is very quick. So you check if the encryptor is running, and then you verify the run. What is verify run? How are you just making sure you want to continue? You could probably remove that. Yeah, no, everything is in a config, and then you can just change the config. And this is the way I did it was really messy, honestly. I did like an instruction. I could have made this a name tuple, I'm pretty sure. And I just ran it all in like this one line bit, and yeah, I was just lazy, honestly. But you verify the run, then you again, this is all, you can disable this if you want. Disable task manager, and this is just a simple, I copied this off Stack Overflow. You can see all this code here. Same thing. Prompt fake dialog. This one I liked because I ran this in a thread, since this, all it does is a bunch of these pop-ups is stall for time. Like this alone, interacting with the Windows API would take probably like a second for all 4 of these, and they're different types too. Okay, maybe they're not different types. And then there's some other like stuff we're gonna look at. Magic exists. You could also just check the database if it is, and these are comments I made a year and a half ago, so, but that would take a bit of time, which we don't have. Okay, so what was this? What is magic for? Attempting encrypt. Okay, I guess it's for like if you don't want to run this multiple times. That's how it would work. You'd run this multiple instructions for instructions, execute instructions. I guess you'd run this multiple times on like multiple daemons or demons. Event. Alright. Shadow copies. So you needed admin privileges for this, but the assumption was that this would be some sort of like optimizer or something, like optimizing your computer. But in fact, it was just a ransomware. And then this was just all copied off Stack Overflow, but it deletes all your shadow copies, and shadow copies are just Windows copies of files that you can turn on. So that like removed the first layer of backup, but if they have other backups, it's fine. Prevent it. This is just standard prevent interrupt. One time clear the recycling bin, also standard. Yeah. Show problem. Yeah. Self-destruct. And this is after everything ran. You just want to destroy yourself so no one can analyze you. This is just a bunch of safety measures since you don't really care if it crashes anymore. And then yeah, just random stuff. I had fun with that one. Replicate to multiple locations. Alright, so rand index is equal to random self-allocations. What is self-allocations? Alright, so testers alright, let's just read this file. Common processes. This is how we're gonna hide it. We're just gonna name it random shit and hope for the best. Get the roaming app. This is where you're gonna hide it because realistically no one's looking here immediately. Roaming app data, and then you just get random file names here. Local app data, temp as another directory. I think. No, yeah. Are these directories? Yeah, I think they should be directories. So back to replicate. So you get all the locations, then file size of the stub. This is the thing you're gonna run, I'm assuming. Stub bytes. What is stub? F.read. Alright, it's reading itself. That's what it's doing. That's kind of cool. So it's reading the current file that it's running, and then it's taking that file, and this is so you can hide. Dude, this is actually devious. So you can hide the exe that's actually running. And obviously you could have like so many more locations than just this. You could have like 200. So index, location, enumerate. Alright, this is just a random key. Oh, we'll look at that later. Random that choice common process. This is so grab a common process, then get this .exe, and then we're dropping different exes and DLLs everywhere. Extension arbitrary with open magic file. All right, yeah, we're just writing. This is just empty bytes. XOO. If index equal random index. Oh, and then these are just fakes. And then this is gonna be the real bytes. Yeah, that's cool. That is very cool. Testers, and then you just append the root file back. So replicating, we are gonna add to registry. And all we're doing is self-reg exists registry key, some random arbitrary number where we're gonna hide a bunch of stuff. I think testers. Oh, this is just auto run, I'm pretty sure. No. This is an auto run. This is where the files are gonna be. All those fake files that we seen before. So, oh yeah, that makes sense. So you get the random thing, and then you put that there. That's shell. That's shell. Drop files that we have encrypted. All right. Did I miss? Where did it get encrypted? Go to references, mask encrypted. Where did we get a mask encrypted, bro? Oh, I didn't see that. This was supposed to be an in-depth analysis, and I forgot the init of this entire big processor function. So first we got a command center. Let's look at command center. Command center is the main class for the command center application base URL. All right, so this is just a regular request section. So we're just sending requests over to the Golang server that we look at later. init ransom, and then these are the endpoints we have hosted on the Golang server. We got the base URL. Then we send over the hashes. All right. I guess we're looking at this now. Device info. All right. Host name, local, public IP, MAC address, OS, platform, version, release, HYW ID, disnum. These are all just string or none. All right. This is how we get the hardware IDs copied and pasted from Stack Overflow or ChatGPT. Likewise. And then you take all of this, and this is how we hash it. Realistically, I feel like this IP shouldn't be here since if you use a VPN, now it's all messed up. So then you just take all this, get the MD5s, and then you get all these hashes. Oh wait, never mind, you're hashing every single one of them. Oh my god, I'm fried. Alright, next we got the mask crypto, and then the mask crypto is actually what's doing all the work here. We have an encryption config .zz, which is ransom config prevent. Yeah, it's just all the stuff you can do. Alright, don't need it. Alright, key. Alright, let's just get into it. This is the public key. You never actually have the private key in memory, so you can't actually recover the files once it's encrypted. The C2 has a private key. Encryption, you take the encryption config, self.filer. We have to look at filer real quick. Alright, this is I'm like jumping around everywhere. This is bad. Alright, this is the allowed extensions that you could use. So basically anything of value. You don't want like all the useless stuff. You don't want to encrypt this stuff since it can mess it up. File, base name. Alright, this is just like it represents a file. Property, if that. Alright, so we get the paths. No, it's just a property. Never mind. Why am I looking at that? Except paths, that just make sure that this function, since you don't want you want to do everything before this runs. Like if this runs, let's abort and then just make sure we have a backup to get back to here, if that makes sense. Entry. All right, let's just go to the bottom here. Traversal. Okay, first you get all the drives, then for each drive you set up a thread and you run these threads and then you join the thread. So for each drive there's a thread recursing everything. And then you go to traverse here. Get the root directory, which should be like C. How do you like? It would be like, oh, never mind. C, D. You can get like USBs in there too. I'm pretty sure. Never tested with that, but. And we have an apply function. This is what we're gonna run on each of these. Inner traverse. If entry is file underscore allowed equal include all or suffix in allowed extensions. Alright, so we're just making sure that we should keep this file and not or throw it away since we don't want to encrypt it. If apply, and this apply is obviously the encrypt function. You take this with self.lock. Obviously we have to have our concurrency safety. Yeah, that makes sense. Self.follow.append file. If m is none, else m.append file entry.path. Alright, so just get all the files that we have encrypted. If m is none, yeah. Alright, and then obviously this is when it's a file, but the first time around it's gonna be a directory, an entry name.lower, and then you're just gonna do it. Obviously, you just traverse it, and then each time it will just come back. Hey shit, yeah. That's how you get the drives. I copy paste. I remember this exactly from Stack Overflow. Back when I actually used Stack Overflow, and I was just like Claude. Good old days. Alright, back to Mass Cryptor. Yo, this is gonna take forever, holy. Alright. Alright, back at the Mass Cryptor, we have the self-thought limiter, and limiter is just making sure you don't go over the thread limit. And honestly, this code was basically like one-to-one with my Golang stuff. You get the max threads, you create a lock, and then you create a semaphore. Yep. Self to active threads, you get total threads, active threads. Alright, total threads, worker, whatever task you have, yeah, whatever. Or acquire thread, worker, self.lock, thread.start. So you're just adding a task to it, and then you're starting the thread task. And then you wait for the threads, and then you clear it, and then resets an alias for close. Alright, cool. That stuff's kind of important. vpath here. Alright, so where we're running from right now, again, then we get the path here. Nope, that's not anything we wrote. Encrypted list, absolute path, all the encrypted files as a property. Encrypt, recursively encrypt all files on the system. Alright, and then this is our encrypt function that I was talking about. Don't encrypt the current running program, obviously. Don't encrypt already encrypted files, and this was a prefix for encrypted. So if they remove that file extension, it would get encrypted twice, which is no good. So traverse all, then you get all the encrypted files that we just did. We add tasks, we get a post hook for each file. What's supposed to encrypt the file? Alright, we rename the files here. Here we go. We rename all the files. And decrypt. Alright, add task. And then once we're done, we reset the limiter and we wait for the tasks to finish. Alright, decrypt now. If file is none. Wait, did I use for limiters? Did I use threading? Wait. Alright, this is a mistake. I should have used multi-threading here instead of, or multi-processing. If I use multi-processing, multi-processing, import, what is it called? I rarely ever use. You got process, and then you got worker? Nope. Well, pool, it's like pool something. Pool. Here we go. If you get the return pool processes. Alright, I have no clue what I'm talking about. Let's cut that out. File if is else file. Alright, cool. Assert none. Alright, if this doesn't like this aborts everything. It's an exception. So self that back up here. Make sure you don't decrypt, since decrypting doesn't do anything good. And then also make sure, why would or file why would we return here? That doesn't make any sense. Would it not be if not, if same file or not? There we go. All right, decrypt. All right, all this does is take. All right, this stuff is a little bit more complicated. Crypt file. This is how we handle the decryption and the encryption of everything. I didn't realize how much code there is here. I would have ate by now. All right. Take a file, takes the public key, takes the encryption config, puts the public key in our AES wrapper. This is mostly just ChatGPT. Struct dump. This is how I don't know why I even did this, like the C++ comparison of it. And then we got the first 8 bytes, n bytes. I'm assuming, I don't, what is n? Oh, all right. Oh, like the content. I'm fried. All right. 32 bytes at the end here for the hash. I'm assuming, yeah, signature. Size equals struct up hack. All right. UN4. This is the size header to know how much of the content to read, plus the encrypted content. So you add it onto there. No padding needed, or like separator. Then you grab the signature of this message to verify it when you. Where are we sending the signature? Like, I don't know why we need that. All right, but we'll find out later. Message plus equals. You grab the size header, so you read the first 8 bytes. If the size header does not exist, you obviously return. Now you unpack the big NDN. Yes, you went to 64. This is the size header. Encrypted content is equal to, now you read the size. If not, signature is equal to f.read. You read the last 32 bytes. And this all gets consumed as you read it. So you don't have to worry about offsetting it. Message equals size header plus encrypted content, and then you grab the real signature of it. And now you have to compare the signatures to see if it was tampered with. And I use a public key for this, yes, which is completely fine since it's SHA-256. We use RSA for the back and forth since we need asymmetric. I don't know if asymmetric. Yeah, asymmetric encryption, and then SHA-256 is obviously a hashing algorithm. So, all right. So all this stuff is just pretty self-explanatory, and yeah, we even give the privilege of changing their file names back. Courtesy. Yeah. I don't even remember where I was. Where was I? The way I did this was so dumb. I could have used, like, if I used the name tuple, I could have made all this stuff, or at least this stuff, required, and then all this optional, and then you'd have none of this. All right, whatever. All right, then we hide the this is just for trolling. You hide all their original desktop files so you can replace it with your files, and then this is obviously just copied from GitHub or something. I don't know. We'll get to fill screen. Drop magic sentinel. All right, now we just drop this file. This is just a simple write. Yeah, we just make the file. Generate a bunch of files. This is just, again, like, this is just like put fear in people's hearts. Random 6-8 thing. I don't know who cares about the utils. Random 8 string plus an extension. Then you get the self.root.door name with open path with bytes, and then this is just random bytes. Throw it in there. And so it's just random bytes and random stuff. It's not like it means anything. Minimize all windows, close all windows. I don't know if I showed this. Yeah. Again, all this like Windows API stuff, I had no clue. I just copied it. Close all windows. No, I've already been there. Drop the decryptor. With open the current path, read it. Oh, wait. This encryptor becomes the decryptor. That's sick. Dude, I don't even remember that. So after you're done encrypting everything, it skips all that and then just does the decryptor right here. Back to this, path is equal to, so we just drop. All right, this is pretty standard since the bytes are all the same. And then these are just the bottom of the helper functions. If anyone can run decryptor, drop ransom, yeah, whatever. We are no longer encrypting. Yeah, delete the file. Run the decryptor. The sub process, I already showed that. And then self-destruct, obviously. And then this is how we do it. So we just unpack the tuple, which is, yo, Python's such a sexy language. It's actually so amazing what you can do compared to Golang. If run if true. What is run if true? Oh, this. Damn, it's too late for this. If instance, and then yeah, run the callback. Map instructions. All right, that's literally it. This is all of that. Let's get into the C2. Main API. This is all just regular stuff. Let's go to new client first. Oh, that's right under. All right. New router. All right, we use cheat. I've used Go Fiber, Go Cheat. I've used the standard net HTTP. I've used, I think, wait, not Gorilla's WebSocket. Unless I'm wrong, I don't know. But yo, Cheat, I feel like Cheat is the easiest one to work with. Actually, no, I'm lying. No, Fiber is so much easier. All right, so we use these middlewares, real IP, request ID. I don't know, just to add lines to code. Logger, recoverer. Recover is very important. Limit by real IP. All right, this is just a rate limit. And then this is the private key, and obviously no one's gonna have your server unless like the feds just sees you, and by then you're kind of screwed. And then you create a client. Let's look at client. Ransom deadline. All this is in the config. Let's see what config I had. Alright. Forwarder. Solana address. Min forward. Transaction threshold. C2. Ransom amount. Solana 1. Right now that's 84.67. So not bad. 72 hours, so 3 days. All right, whatever, that's cool. Compiler, oh, yo, we'll get into that. Ransom amount. Yo, 200, oh my god. I wish it was 200. Damn, Solana was 200 a year. It wasn't even, dude, Solana was 200 like a few months ago. Not a few months, like 9 months ago. It's not that far away. Alright. Payment callback Snowflake used for, oh, I got comments for myself. Used for the comment payback used for the payment callback endpoint as extra security to prevent people from finding the endpoint. Oh my god, I'm so bad at reading. Alright, so this is just to make sure no one finds the endpoint. Alright, I could have just read the code. Alright, so it's like 8 strings or 8 letters. Payment. Alright, this stuff is so boring. I hate reviewing. No. Alright, this is a mock writer since forwarder was an HTTP thing. So we wanted no HTTP since we had our own, and we did like no dependency on that. So this is just mock writer. Yeah. Parse JSON. Send webhook. Alright, this is just helper functions. Is localhost, yeah. Send webhook. That just sends it to a URI with data v. Alright, getting into the real code. This is the actual like fun stuff. So first, this is on a request. So you got the request right here. Our init ransom body. We have a hashed encrypted key device info as seen before. Parse JSON and this endpoint return success bool UUID string. This is just the unique ID. Time before the activation, that'll be the timestamp. I'm assuming, yeah, in64 is a lot of data. Address is the Solana address amount, and then you have a QR code in base64, I'm pretty sure, hopefully. That's like the only way to do QR codes to string. Payment ID, and then, wait, that was a I don't know, man. And so we just have a random UUID for no reason. Alright, cool. Alright, so we decrypt and then see the RSA is obviously our RSA decryptor with the private key inside. We decrypt the encrypted key that was encrypted with our public key, so then we have asymmetric encryption. This is just a helper function, obviously. I don't know why I keep saying obviously. Alright, hashes.exist. Alright, this is our data. I don't even know if I want to look at the database stuff. Like, it's not that cool. Like, it's just simple MongoDB stuff. Like, honestly, like, a lot of this is just from old projects. I just copy and paste it. Like, it's just a mix of it. Like, the only functions I wrote were match hashes here, and even this, it's just like type in the same stuff over and over again. You just copy it and type it. So where were we? Alright, if it exists, if the hash exists, then we don't even want to interact with them. That's how. Wait, yeah. All right. Then we write the database, grab our request contacts, collection ransomware. All right, this is just some config name, and then you write rs with rs ransomware. This is a database entry. This stuff is so boring. Holy. Process ransom. All right, create payment. All right, c.sola handle that create payment. Ooh, dude, I actually really want to get into the forwarder. That's so exciting for me. Payment create body. All right, so you get the ransom amount. This is the callback URI, and you obviously want this to want this to be localhost so that no one can access the callback URI, since the callback URI is what gives you the private key. Yeah, gives you the private key. So we have the paid callback. So this is after they had paid the money, and then our Solana thing is also on localhost. It's only connecting to. It's not connecting to anything. Maybe for price. I will look at that. Alright. Must be localhost for this endpoint. Yep. This is the ID. URL parameter. Webhook response. Success. ID. Desired amount sent. Transaction ID. Address. Time sent. Percent of total. And I think there should be like a percentage total leeway. Dot filter. So now we find the Oh, that's what the UUID is for. It's for the callback. It's crazy what patience gives you. Alright, got the collection, ransomware, ID. So this just gets to the V. So put that in V. Convert it to a ransomware object. So this is what you have: paid at hashes, activated private key, paid equals true. See the update. Then you update the database. Is that it? Oh wait, never mind. Oh, that's what the hashes are for. You're matching all of the hashes in case the UUID. That's just, it's like a backup. Like there's really no need for them unless you like want to log it, which in that case I don't know. That's kind of like, are you in there for the money or controlling people? It's not even controlling people. Like, what, you can't do anything with those hashes or like that information. See the filter. Alright, so grab the UUID, match hashes. Alright, we're checking the hashes. This is only if V is still nil, since we already predefined these. As you can see, there's no colon. There's no colon, so they're already predefined. And in that case, we match the hashes. Really trying to find them. Then we convert this to a ransomware object, and then we return said ransomware object. Wait, let me read this real quick. Whoa, your important files have just been encrypted. And yeah, I'm telling you, like half of this is me, half of this is ChatGPT. I like modified a bunch of it because I wanted for it to sound fancy. All of your important files have been encrypted with an incredibly strong encryption algorithm. For reference, it would take 2.29 times 10 to the power 32 years with a quantum computer to break the encryption. That is 229 followed by 32 zeros. You will not be able to access them without the decryption key. To recover your files, you must pay a ransom in cryptocurrency. The details for the payment will be provided below. Failure to pay this within the ransom deadline, which is 72 hours, as you can see here, will result in a permanent loss of your files. Do not attempt to decrypt the files, change the names, don't change their names, or delete any files, as this may cause irreversible damage. Follow the instructions carefully to make the payment. Once we confirm the payment, you will receive the decryption key. Payment chart. Go to the following address to make the payment, and then this is our placeholder /s, which is string. Send /d. This would have to be /f. Solana to the address above. Once the payment is received, we will automatically decrypt your files for you. Remember, time is running out. Act now to prevent the loss of your important files. Oh, and we got a short message just in case. All of your important files you may. Oh wait, this is probably something else. The GUI. This is like 90%, not like, yeah, 95% ChatGPT. I just changed like this stuff, and then all this, like maybe like up to here is me, and the rest is just not me. Ooh, yo, I knew type checking back then. It wasn't that long ago. All right, so this is the most important part. Like, obviously, without payments, you're not making any money off this project, and it's a waste of, like, complete waste of your time, right? So we have to look at the forwarder, and honestly, I'm so excited for this. Let's look at the config. Rate limit forward address. This is obvious. the way I built it was I was too lazy to do that stuff, so I just put it in a config. Like I didn't have an actual application for this use. .env bin wall bins are cmd. Let's open all this up here. All right, this is if this looks familiar, this is literally the exact code. Told you. So, and a lot of this with ChatGPT as well. So let's look at the Solana stuff first. This stuff is actually like tickles my brain. All right, so we got listen for transaction ID, CTX address or transaction address string callback. We got a websock.log results. Nope, that's context value. Oh, the signature error. All right, that's all we need to know. We have the signature in there. RPC, that commit type, and then there's like multiple types you got here. No, not that shit. Commitment finalized, confirmed, process. Process is the money still isn't in your account. You would want finalized for the max blocks. All right, so convert the address, or no, take the public key from the base 58 of the address, since I guess Solana addresses are base 58. Then we're gonna lob subscribe to all transactions that mention the provided key. Signature RPC event. Alright, so you take the signature. Oh, dude, this is, I think it's too late. Oh good, I gotta finish this. Transaction that's on the blockchain will get sent to this webhook here, RPC event, and we have the event just in case, since we want to be finalized and stuff. Case. All right, so if the CTX is done, then we just return the error. It'll be like canceled or whatever. Default receive. Hit CTX, obviously same transaction, and then we run the callback, which will be provided. All right, so we got get confirmations. I'm gonna just run through these real quick. All right, grab the signature, get the status of the signature. This is just what Solana thing is. Solana does literally all of this. Like, I don't understand any of that. Status values, get the values finalized or confirmed. Return math and max int. What up? Alright, so I was too lazy to get the max blocks or whatever, so I just give max int 16 for whatever reason, and then get the confirmations. Int 16 is what? I think I was too scared to use int 8. Confirmations do not go up to 255. I think at most maybe 6. Alright, get transaction. This just gets the transaction ID. Get parsed. A lot of this is documentation. Just copy and paste from documentation. Instructions. Alright, get all the instructions. Marshal JSON. Get RPC on instruction type. What does this do? Return the value of the transaction in Solana. So you go through all of the instructions, then you check if it's a transfer type, and then you grab the LAN ports, and the LAN ports are the I don't know if it's for all. It's not for all of crypto. It's only for Solana. Solana is the only thing that has LAN ports. There are 1 billion LAN ports in one Solana. Huh. Well, you know. Convert LAN ports to, and then this is, you have to use big dot float for everything, which is kind of annoying. But it's whatever. Convert LAN port. And then you got some helper functions down here. From to fee. Create m transactions. Create multiple atomic transactions that are bundled together. If one of the transactions fails, the entire bundles fail. Well, yeah, no shit. Wallet pair, that's public and private, yeah. Simulate, this is for simulating the Solana transaction before it happens to see if it like will go through. I think you pay fees on that though, that's the thing. You get your contacts, build transactions. Alright. Transaction bundle from to amount. These are all the wallets. wallet account.public ham. Alright, so we got create wallet, create new wallet, so create a new pair. Wallet balance, get the wallet balance. Once, yeah, get balance, yeah. Or just literally just the RPC. Requesting airdrop, encode the key, write temporary wall.dat. We need the we need a write ahead log just so that the transactions don't drop. Dispose must only be called when the wallet no longer has balance. These are all like the ransomware wallets. Damn, this is actually like a good system. I delete the wallets as soon as they're no longer in use. I mean, realistically, you probably have to send this along to a like one of those like fixed float or side shift to convert it to like, I don't think, no, those don't have XMR, do they? There's no way. You have to use like one of those probably one like Bisq to convert it to Monero, and then you can throw it out. But then you'd have to have a whole Monero thing. Pretty complicated stuff. From file, let's just you get the file, and then you get the public and private from the file. Yep. Cool. Create QR. This stuff's just, again, copy paste the QR code, new, just creates a new QR. Yeah, no, it's just API call stuff. And this is where you have to put in like the metadata for it to actually work. And this is, if you scan the QR code, it'll send you immediately to the amount. Bow error, wallet balance, wallet. Alright, so you get the wallet balance, then get the balance in float 64. Then you transact one singly transaction bundle, create a bundle, get fee for message. So you just turn this into a message, and then base. This is RPC calls, bro. I keep explaining them. I have no clue what I'm talking about. Like, genuinely no clue. Like, this stuff is completely foreign to me. I have maybe like an iota of a clue. It's a cool word, iota. It's actually a Golang keyword too. Windsurf. Alright. Fee is equal to nil. Fee.value. Alright. Yeah, cool. Total LAN ports, how much balance you have, amount, and then we're just sending all the money. yeah, this is pretty self-explanatory. Simulate it if you want to simulate it, build transactions, and then you send all the money as much as possible. It should be 100% though. Alright, so we got create payment. If not string line. Alright, this is just adding HTTPS and HTTP. Callback URI, localhost. Alright, yeah, okay. Bad request. Alright, cool. Let's go to the real stuff. Payment, create response. Success, ID, amount, expires. Alright, so crypto deadline. Oh. Create wallet. Then response dot address is equal front dot. So then you get the public display of this. Then you write temporary, which just writes the wall dot that. And you want this, of course, so you don't lose the freaking private key. Then create a QR code of it. We've seen that code already. With deadline, context set background. And then you add this. Oh, that's kind of cool. The deadline is literally the crypto deadline. Like, I had no reason to do that. No, I had every reason to do that. What am I talking about? Listening for CTX response address. Alright, log result, handle webhook call. Alright, cool. You just handle the webhook call. You get the transaction. Alright, this is like what the transaction is, and you want to see how much got sent. Value, tx.value, big.float, get the big.float. This is how much you can, if the amount is too, why is this constant? Minimum amount to forward in Solana. Alright. Then you got threshold for amount. Okay. Handle web. Okay. Success, ID, desired amount, sent, transaction ID, address, time sent right now, percent the total, how much actually got sent, if amount, transaction threshold. Then you send this webhook all the way back over, and then you forward the funds. Send all balance to forward fund. Boom. Freaking genius. Alright. Handle. Yo. That's it, right? Just about it. Yeah, there's no way. Alright, I'm gonna go eat. See ya.